And then another thing I went over in the video, if you take 1 over the magnitude of v times v, which we often write as v divided by the magnitude of v, but it really means v times 1 over its magnitude. What kind of vector is that? It's a unit. In other words, it's 1 unit long, right? It's a unit vector. That's really important for you to know that, because oftentimes in applications, you want a vector in the same direction as a given vector, but you want a different length. So for instance, a cable. So if you have a cable holding up like a telephone pole, that cable will have a certain amount of force on it. And that force will be in the same direction as the cable, but the length of the cable won't represent the amount of force. So in order to get a vector that represents the amount of force in the direction of the cable, you could take a vector that represents the cable, turn it into a unit vector, and then multiply that by whatever the force is. Find a vector that is 6 units long in the direction of -2, 1, 3. So this could be where your cable is headed in your coordinate system, but maybe the force is 6 newtons or pounds or 6 million pounds, whatever. How do we do it? Well, we turn the v into a unit vector and then just multiply by 6. That's the trick, and it works nicely. So how do we, okay, if you know that v divided by its magnitude is a unit vector, what does this little formula tell you to find first? Magnitude of v. Okay, we can do that. So magnitude of v is the square root of this guy squared plus this guy squared plus this guy squared. So I would at least like to see you square the components and add them together. You don't have to put -2 squared. You could just put 4, right? And then you could just put 1 squared is 1, 3 squared is 9. I at least want to see this much work. You were just giving me the answer because you did it in your head. But on the test, I won't know if you did it in your head or you took one of your fancy calculator programs and had that do it for you, right? So I do require a little bit of work there. And then, of course, that is root 14. Okay, so the unit vector would be 1. You could take 1 over root 14 times the given v. And if you were just looking for the unit vector, you could stop there. But we want a vector, so that if you were to find the magnitude of that vector, it'd be 1 unit long. But if we want a vector 6 units long, just multiply by the scalar 6, and you have it. So this right here is v divided by its magnitude, or 1, really, the way I wrote it as 1 over the magnitude of v, 1 over square root of 14 times v. And then to get the vector you're interested in, multiply by 6. So you get 6 over root 14 times the vector -2, 1, 3. And a question often comes up, do I need to scalar multiply out the 6 divided by root 14? Well, not in this example, because you weren't told that you're going to use it for anything. But if you end up needing to add this to another vector, then yeah, you gotta scalar multiply by 6 root 14 in order to add corresponding components, right? But if this were like a test question, I would stop here because you're less likely to make a mistake if you stop here and then move on, right?